Hi everyone, today we're going to continue talking about functions. More specifically, we're going to get into a discussion of domain and range when looking at graphs. So our previous lesson was all about determining domain and range when you were looking at an equation or from a table or from a list or from one of those diagrams, those set diagrams. Here we're going to talk about when we're looking at a graph. So a few things first. The first thing that we have to do is make sure that it actually is a function. And the way that we do that is with the vertical line test. I like to refer to that as the VLT. And the vertical line test simply states that I should be able to draw a vertical line anywhere through my graph. And if I only intersect the graph in one spot, then it is in fact a function. And I would have to be able to do that vertical line anywhere. In this case, I can do that, and so this would be a function. And the reason that holds true is because along that vertical line, all of the x values are the same. If I intersect the graph more than, or intersect the graph more than one time, then in fact I have one x value corresponding to two different y values, and then it wouldn't be a function. So that's what the vertical line test is doing. It's just graphically determining that every x value corresponds to only one y value. So in this case, we do in fact have a function. And so let's talk about the domain and range of this function. Remember that our domain are all of our x values, so I'm looking for my smallest x value and my largest x value. And sometimes when people look at a graph like this, they say, oh, well, I'm crossing the x-axis right here and right here, so that must be my domain, goes from -7 to 4. And that's incorrect. Those are your zeros. You have a 0 at 7 and -7 and a 0 at 4, but that is not representative of your domain. I'm looking for the smallest value. These arrows on the ends of my graph are signifying that this graph continues on and on forever in the negative x direction and in the positive x direction, which means that my domain would go from -infinity to +infinity. Let's look at the range. So for the range, that's our y values. I'm going to look at my smallest y values, determine if I have one. And if you look at this graph, it goes down. It only goes down as far as this part of the graph, which is at -6. So it actually does have a minimum value, that minimum being -6. And it actually is at -6. We include -6, so we put that square bracket. On the other end, we're going up to +infinity. Those arrows are signifying that. And so our range would go from -6 up to +infinity. This is kind of a trick question because when you look at it, first thing people want to do is start getting their domain and range, which technically you could, but if I'm asking you to find the domain and range of the function, clearly this is not a function because it doesn't pass the vertical line test. So this is not a function. It doesn't mean that it doesn't have domain and range. It just means that it's not a function. Okay, you could look at your minimum x and your maximum x values and your minimum y and maximum y values, right? So your domain would go from -1 to 5, and your range goes from -3 to 3. So you can find domain and range, just make sure that you signify that it's actually not a function if that's the question that they're asking. Okay, this is an example of a piecewise function, a discontinuous function. When drawing it, you actually have to pick up your pen to move it to complete the graph, so that's considered discontinuous. And just for ease of this example, all of these, if it looks like they're open circles here, these are actually not. This is just a straight line here. I just want to be clear because that example is kind of hard to read. And also this graph didn't put arrows on the end, so I'll go ahead and do that. Okay, so this is just a continuous line here. However, here there is an open circle. And so at first glance, some people say, well, that's not even a function, because if you did the vertical line test, you're actually intersecting the graph twice. And my argument to you is, well, technically you're not. This is an open circle, so the graph doesn't exist there, it only exists down here. So in essence, you're really only passing through the graph one time, which means that it actually is a function. Okay, so let's go ahead and look at the domain and range of this function. Our domain, I need to find my smallest x and my largest x. So my smallest x, because of that arrow on the end, that tells me I'm going from negative infinity. And then this arrow on the other end says I'm going up to positive infinity. Now, here, I don't have any break in my x values, because even though there's an open circle there, there's a closed circle here, so I'm picking up that 1 down here. That's where you have to be careful, okay, because it is picking that up there, so all of my x values are included in the range. I'll show you an example where that changes. Okay. The range, same idea, right? Our range in the negative direction goes to infinity, negative infinity, and in the positive direction, it goes to positive infinity, and it's pretty straightforward. So even though the graph is a piecewise function and it's discontinuous, it still includes all of the values from domain and range. Okay. And let's look at, I'm going to jump around here a little bit. Let's look at this graph. This is a little bit different only because it has a beginning and an end. And so it's going to look a little bit different when you're filling in the domain and range. The domain, your smallest x value here, right, is at 1, and your largest x value is at 5. I say 1 inclusive and 5 inclusive because there's a closed circle there, so it does in fact include those values. And so my domain goes from 1 to 5. Okay, similarly with my range, right, my smallest value is here at 0. My largest value is up at 3. They're closed circles, so that's inclusive. So my range goes from 0 to 3. Okay. I am going to go down to this one, and then I'll jump back up to that other graph because there's one quick thing I want to show you on there. So this is also a function. It does pass the vertical line test. It is a discontinuous function, and it is a function that has some holes in it. And so I do want to talk about that because it is important that we have to be very careful when we fill out the domain. So our domain goes from -2 is our smallest value here, right? -2. There's an open circle there, so I can't include -2. Okay? And I'm continuous all the way until I get up to 0 for x, right? But I can't include 0 because those are both open circles. And now how am I going to fill in the rest of this? Well, remember when we were first talking about notation, right, back in the review section in the last unit, we said we can use this, the union of sets, right, because it includes everything in everything in the union. So now I say, okay, well, now I have 0 all the way up to 2 because there I also have an open circle. And then I'm going to say, well, now I go from 2 all the way up to 3 where I have another open circle. So that's how you would write out the domain for this particular graph. Because of the holes in the graph, you have to account for those in your domain. When we look at the range, our smallest value in the range is at this -10. And here's where this can cause a little bit of trouble for people. They say, oh, well, there's an open circle, so I can't include -10. but in fact you would, because in this part of the graph it is included. Okay, so I am going to include -10 as part of my range. And I'm going to go up to +10. And it looks like my graph, there is no y value here, right? It doesn't actually include +10 here or over here. And so I go up to 10, but I can't include 10. However, I can go from 10, then continuously up until 20, not including 20. Okay, so when you have these discontinuous functions, especially when you have discontinuous functions with holes, you got to be careful to make sure that you account for all of those holes when you're writing your domain and range. The only other thing I want to talk about is finding a specific value from a graph. And what I mean by that is, if you're given an equation, so for example, if your equation was f of x is equal to 2x, and I asked you to find f of 1, you would just plug 1 in for x, right? And you'd say, oh, well, that's 2. Well, how do I do that when I'm looking at a graph? You're actually going to do it the same way. You're just going to go to that x value and figure out what the corresponding y value is. So in this graph, let's say I'm going to ask you what f of 3 is. Well, you're just going to go over to 3 on the x-axis there and figure out what your y value is at the graph when x is 3. So if I go out to 3 here, my graph is up here, and that corresponding y value is just 2. And sometimes people forget that. I just like to go over that quickly because it does come up, right? You're just evaluating the graph at a particular x value. One more quick example. What is f of -2? So go to -2 on your x-axis, and where is your graph? Your graph is up here at 1. So that's it for this. I will see you in next class. Take care, everybody.